Now, I'm not going to have a fire extinguisher this year here up on stage, but I will have some fires like I did last year, so, but not as many, so there we go. All right, well, welcome to DDD Europe, first of all, and a talk on really realizing domain design through architectural modularity and service granularity. What I'm planning on doing on this talk is talking about the differences between these two and how we realize our core domains, maybe our subdomains and even bounded contexts through architectural modularity, and also the association of bounded contexts and services. So when we start talking, there we go. When we start talking about these differences, modularity is about the breaking up or partitioning of our systems into multiple parts. And then granularity is about the size of those parts. And I'll be talking about each of these. Now, one of my well-known quotes that seems to have gotten out there on the internet is this one right here. Embrace modularity, but beware of granularity. Because it's with granularity that we usually get into trouble. And so I'll illustrate exactly what can happen with that. But let's start our journey with architectural modularity and what that really means, and specifically why it is definitely a trend in this industry, and it has been for about the past 8 to 10 years, that we take our large monolithic systems and we insist on breaking these up into smaller pieces, maybe as far as microservices. When we talk about distributed architectures, this is definitely a trend in our industry. But why? Did we ever start or stop to consider why is this such a trend? And that's what I really want to introduce in this section on modularity. So what you see here is a knife. And what does this knife do? Yeah, it cuts things. Yeah, exactly. And a lot of times, this is what our systems look like when they start out. Now, I have this knife, and I use it to cut things, including my fingernails. But every time I try to use this knife to cut my fingernails, I keep cutting the tips of my fingers off. And I have to keep putting Band-Aids on them. And it's really hard to type and write code when your fingers are all full of Band-Aids. So what do? Well, I want more features. And like our systems that we build and products, customers want more features. Can you please add a nail file and some scissors onto this knife? It would make it much more useful. That's a great idea. And so what happens? Like our systems, this knife starts to evolve into something that looks like this. Now I'm no longer purchasing boxes of Band-Aids every week. I've got a nail file and scissors. This is great. A lot more useful. Except I buy this knife. But I like to go to the park or meet friends or maybe, open up a bottle of beer or wine. And I keep breaking the scissors every time I try to open up that beer cap. And so, can you add those features so I can take this to the park or meet friends and stuff? And they're like, that's a good idea. And so, like our systems, this knife starts to grow and evolve with additional capabilities, and it starts to look like this. Aha! Now I can open up that bottle of wine. I can actually open up a bottle of beer. I've got a can opener. I've got a saw. Now, I'm really not sure what I would use that for unless you get a really bad cut on your finger. I've got a saw to basically saw your finger off. Okay, more Band-Aids, but still. A lot more capabilities. I even have a hook here. Who knows what that's for? Well, this is a good knife, but my favorite activity is hiking, backpacking. I love backpacking, whether it be in the mountains, in the forest, in the desert. It doesn't matter. It's my favorite activity. And I take this knife along with me. But usually I do some fishing in order to eat. And, my eyes are starting to get a little older, so I'd like a magnifying glass and just some other features that would help me on hiking. Can you add those? That's a great idea. And like our systems, customers want more features, more capabilities of this system. And so consequently, the knife starts to evolve into something that looks like this. Now, this is actually the knife I own, except funny, it's no longer a pocket knife. No, this was too heavy to fit in my pocket. This goes in my backpack, but look at how useful it is. It still has that hook, whatever I'd use that for, but now I have a fish scaler. I've got that magnifying glass, a pair of pliers, so that when my boots freeze up, I can actually get the laces out. This is awesome, useful. But what happens? Like our systems, customers want more features. And pretty soon, this knife evolves into something that looks like this. Now, this is an actual knife. You can purchase this. Good luck. It weighs 7.5 kilograms. Folks, this is not going with me hiking. This is not going with me to the park. As a matter of fact, I can't even trim my nails with this. Yes, this is what happens too often with our monolithic systems. They grow over time to additional capabilities and features. But look at all the capabilities here. This is amazing. On the bottom side, I have tools to repair my car or my motorcycle or my bike. That's awesome. If we keep moving over, do you have problems with your teeth? Just come see me. I have a knife that has all these dentistry tools. I can extract a tooth. I can do a root canal. I've got some medical syringes here. I've got a knife of knives. That was our Edward Scissorhand knife. Yeah, look at all these wonderful capabilities. Folks, this knife is totally useless. I can't take it hiking with me. I can't use it. Why? It's too big. Oh, by the way, do you all want to see something absolutely amazing? Are you ready? You ready? Guess what? It's still a knife. That was our original design. That was our original system. But it grew into something that looks like this. What would make this knife more usable? Because admittedly, there's a lot of great features here, but I don't use all of them all the time. What would make sense is to take a Sawzall, a metal cutting saw, and just start cutting this saw so that I have groups of tools in a smaller knife that I can carry around with me if I'm going to repair my bike or my car, or if I need to do some dental extraction, or if I need my knife of knives just because I like knives. Yeah, that would make it much more useful. My point is this. Monolithic systems over time, what we typically call legacy systems, grow to get too large and unusable. So this is one of the why reasons. But there's another reason that I want to show you. Now, this is a technique that I typically use at my client sites to be able to describe why I would like to break apart our systems. So I'm going to try to stand right here. So on the camera, I know this is recorded. We can kind of zoom in on me so we can all see actually what's happening. But basically, here's the analogy. This is another reason why modularity is so important. Distributed architectures are so important. Take a glass, a clear glass. Now that represents our server or our virtual machine. And it's the largest one we can obtain. The water represents the system, the application, the product. And what happens over time as we continue to expand, get more customers, open new stores? What's going to happen here? Pretty soon, I'm going to make a big mess. But look, that water, which represents our system, is almost maxing out the capacity of that server, that virtual machine. Threads, memory, CPU. How much growth do we have in our company right now? Not a lot. This is not sustainable. Please don't open up another store or office or get more customers. The system won't handle it. Oh, well, why don't you just get another server? Oh, sure, we'll still have to do that. But look what happens. If I try to scale this monolith, what happens? I pour the water, duplicate that water in the other server. Folks, we still have no growth, no sustainability for growth in this company. What I'm proposing is this, that we break apart our application into separate pieces. Now, look at how much growth and sustainability we have in our company now. It's a really great analogy for describing breaking apart systems, moving to a level of modularity in distributed architectures. I didn't make too much of a mess. There's a little bit right here. It's a great visual. We are here at DDD Europe. What does DDD stand for? Domain-driven design. It also stands for something different. Demonstration defeats discussion. We could talk all day to management, to our product owners, to describe why we need to break apart our systems. Demonstration defeats discussion. That is a great visual for saying, how long do we have? Because when we break apart our systems, the problem is it's costly. There's effort. And what we are doing there means we can't do other things that we want to implement. We better have a good justification. As a matter of fact, let me show you 5 technical drivers for moving to a level of modularity. The first of those is maintainability out of the 5. Now, maintainability is the ease in which we as developers can locate what code needs to change for a particular feature, locate a bug, add a new feature. Well, in our large monoliths, I think the changes are all here, but I'm really not sure. I'm not sure if we need to change any other area, but, after we test and deploy, we'll find out if we did that wrong. Yeah, maintainability is not great because of that. Who really fully understands the monolithic code base? Yeah. But if we move to a level of modularity, and we're going to assume, by the way, because I know you have this question, all of these services, separately deployed units of software, are all independent of each other. I know exactly which service to make that change. It's an understandable code base. I can make that change a lot faster. The next driver is testability. Now, testability is about 2 things: the ease of and completeness of testing. How many bugs is it possible to introduce into my system? Well, over here I make a change. What do I test? Well, what do you mean? I test my change. Yes, what should we test? The entire system. Did I break anything? I don't think so. I'm pretty sure that's all we need to test. No, that's our testing scope, folks, the entire application. However, what if we move to a level of modularity, where now I apply a change? My testing scope is a lot smaller and a lot fewer tests to run. 23 tests for that particular service, as opposed to 12,000 unit tests in our regression testing suite. That takes us hours, days to test. Yeah. The third driver is deployability, another capability that architecture supports. Now, deployability is about 3 things, everyone. It's about the ceremony in deploying our software. Yeah, we'll get to that. It's about the frequency in which we can deploy our software and the overall risk when we deploy it. I make a change over here in my monolith. What do I have to deploy? I have to deploy that entire unit of software. It's a single deployment unit. What's the ceremony? Oh, well, let me tell you. Thursday, we have our code freeze. Friday, we do our mock deployments in our regression environment. And then on Saturday morning at 2 a.m., we go to release, and of course it fails. There goes my weekend. Welcome to IT. Yeah. What's my overall risk? Really high. And because of that, what's our response? Oh, well, let's not deploy too often. Great. Monthly deployments. I love it. You know, this is the hardest thing we do in IT, is deploying and releasing our software into production environments or to our clients. Monthly deployments. You know, practice does make perfect. We get the opportunity to practice deployment 12 times a year. No wonder we'll never get it right. Scalability is another aspect, because here, well, let me finish up here. I just got too excited about the monoliths. But here's my deployment unit. Frequency, daily. Different services can deploy all concurrently, daily. What's my ceremony? Type, enter. Green light, wait for it. We're deployed. 2 o'clock in the afternoon. There we go. Now I get to enjoy my weekends. And the risk? Fairly low. If I fail that deployment, I'm not destroying everything else. All right, scalability. Yes, I was told a couple weeks ago, oh, modular monoliths have infinite scalability. Yeah, is that really true? Because sure, can I scale a monolith? Oh, absolutely. And I'm scaling 100% of that functionality, even though I don't need to scale it. And what's my mean time to start in a large monolith? That's what scalability is about. How fast can I respond to load and need? Measured in minutes. Is it 2 minutes, 5 minutes, 10 minutes? Ouch. But over here, in this level of modularity, I can scale at a function level. Only those features and functions that need to scale, I scale. Much less cost, much more efficient, and my mean time to start is measured in milliseconds. A couple of 100 milliseconds to typically start up your average microservice. And finally, fault tolerance. What happens if I have some code here that starts spinning up some threads, and we've got a weird condition where that routine exits and does not close the loop? What's going to happen in about 10 seconds? Boom, out of memory. Told you there'd be some fires. You know what happens over here? That same code that starts spinning up threads, closes, and forgets to close the loop. What happens? Yeah, that service goes down. But everything else remains active, fully operational. And my mean time to recovery is in milliseconds, not minutes, when that monolith fails. These are the 5 main drivers for moving to modularity. This is the why piece. We have the knife, we have the water example, and now we have these drivers right here. This is awesome. Until it's not. What happens if all these services start talking to one another and needing to get data or additional functionality? Yeah, what happens to maintainability? Good luck trying to find where to change the code. What about testability? Oh, yeah, this is actually worse than our monolith. I have to test everything. Oh, what do you think about deployability? I want to deploy that middle service. Please don't. No, it's too risky. Yeah, we've lost all of our deployability. How about scalability? What if I wanted to scale the service 2 from the bottom? Yeah, right. I would have to scale everybody. And you remember that little piece of code that we had that all of a sudden spun up a bunch of threads? Yeah, that service went down. And what happens? I bring everything down with me. Yes. This is the cautionary tale, because this actually is worse than a monolith. Ouch. Okay. You know, I bet you're all wondering, does architectural modularity require a distributed architecture? And because what we have available to us is a very popular monolithic architecture style called the modular monolith. What about that? Admittedly, yes, that still has modularity, architectural modularity. Well, let's analyze. What do you think about maintainability? Yes, because in that modular monolith, we are identifying modules, domains. And now, from a maintainability standpoint, I know exactly where to go because that's the way my application is partitioned. Testability becomes a lot easier because I can actually measure and know the dependencies between domains. And consequently, I can be more assured that I've completely tested. So good. So far this is looking good. Oh, what about deployability, though? Ceremony, frequency, and risk. Well, I still have to deploy the entire unit. Even if those modules are represented as jars or DLLs or gems or packages, it still is all combined into a single deployment unit. We really gain nothing from a deployability standpoint, with the possible exception of a little less risk. How about scalability? Nope. It's still a monolith, folks. Whatever kind of unstructured or layered architecture we have, the modular monolith still has to scale 100% of the functionality. And what about fault tolerance? Yikes. Folks, it's still partitioned by domain, but guess what? If we have that little thread over here that keeps spinning up, yeah, that's going to go down. Nothing changes here because that particular domain goes down, everything goes down. Kind of interesting story, isn't it? We do get some benefits, but you can see why distributed architectures, things like service-based architecture, microservices, event-driven architecture, space-based architecture, and all the various hybrids of these are so important and so powerful today. Okay, so let's take a look and close out modularity by kind of looking at domain design and how it's reflected through various architectural styles. No. Let's look at the primary behaviors. Now, this avoids the argument of, well, you're specifying a domain here. That's not really, you keep using that word domain. I don't think it means what you think it means. Yes, maybe it's a subdomain, maybe it's a bounded context. So I'm going to turn it to primary behaviors. And let's take a look at how various architectures actually realize the effort we do through domain-driven design. So I'm going to use a quick example here of a trouble ticket system where customers purchase our electronics. And if they have trouble or a problem with it, they can enter a ticket, and our customer-facing experts go to their home or office and fix the problem. Well, here we've got 5 primary behaviors. You can call them domains, you can call them core domains, subdomains, bounded contexts. It really doesn't matter. These are the core primary behaviors because we need to have customers register based on their support plans. We need to have customers create tickets. That's a whole big portion of this system. But we also need to process those tickets. Find experts, route it, have the expert go to the home or office and complete tickets. But also, we send out a lot of surveys. We receive surveys to find out how we're doing. And finally, there's the whole aspect of ops reporting. Expert reports, ticketing reports, financial reports, forecasting reports. So these are our primary behaviors. Call them domains, core domains, subdomains, doesn't matter. Well, let's take a look at a couple of architectural styles. The modular monolith is what I mentioned here. How do we realize this effort of behavior partitioning in this architectural style? It is a monolith, as we saw. Those primary behaviors, those domain areas, are identified by the primary high-level partitioning of this architecture. Here's SysOps Squad. That's the name of this application. We have a high-level directory or namespace, refers to as registration. That defines that primary behavior. We continue on to say, well, we need ticket creation. And you notice this directory structure or namespace, the way our code is structured and implements this architecture, reflects at the highest level those partitions. Yes, even in a monolith, we can realize our domain-driven design artifacts through our source code. Okay. Let's take a look at service-based architecture. This is a hybrid of microservices that allows us to be able to share data. These are called domain services. Generally, we have anywhere from 3 to maybe upwards to 12. That would be a little extreme, but we could go upwards to 12. In this architectural style, which is distributed, we realize our primary behavior partitioning through the services. In other words, each separately deployed service represents that primary behavior, whether it's a core domain, a subdomain, or a bounded context. Typically, the bounded context would be within these services. And finally, we get to microservices. Yes. Here, we're going to talk a lot about this when we get to granularity. But basically, those primary behaviors are represented through groups of services. Could be 2, it could be 10, it could be 200, it could be 2,000 microservices. All those represent that primary behavior. Now, typically, with microservices, what I do is instead of having a unified API gateway, I will actually physically manifest those primary behavior partitions through separate gateway, API gateway clusters. So we might have, for example, here, our registration gateway API, our ticket creation API gateway, ticket processing, ops reporting gateway. And this way, I can physically identify that domain and all corresponding dozens to hundreds of services representing that primary behavior. All right, well, let's finish up this talk. Well, finish up. We're only halfway done. Let's finish up, though, by talking about domain design and service granularity. No, primary behaviors. Doesn't matter what they are. And now we're going to really get more into bounded contexts and a little bit less about the actual core domain or subdomains we identify through that effort. So how many services do we typically have in a bounded context? You're right. There we go. So here's our domain-bounded context that we form. And typically, it's represented through a single physical bounded context, a microservice and its corresponding data. It could be 3 services. It could be 5 within a bounded context. And let me show you why. So generally, we make the assumption, and you are correct. Generally, we can assume each bounded context has its own service. But let me show you that fallacy. Okay, so this really points to the granularity. How big should a service be to fit within that bounded context? Well, this is a balance and a trade-off between 2 primary drivers. We have disintegration drivers, which tell us, no, you should break that service apart. But it's within a bounded context. I know. We can still have multiple services. I'll get to the data piece in a little bit. But then we have integration drivers to say, and no, you should put all those 4 services back together. And it's the balance between these that we arrive at the number of services that we should have in a bounded context. And let me illustrate these 5 drivers. The first of those is service functionality. We call this single responsibility principle, which is the S part of Solid Principles by Robert Martin. We talk about single purpose, high cohesion. That's what this driver is all about. Now, let's look at a notification service. So this is in a bounded context, has its own data. We can actually notify customers through SMS, email, and actual postal letters we print. Question, though, should that be 1 service or 3 services? What really is single purpose? Because these 3 services are still part of the notification context, meaning, depending on the data, those might all still be in a single bounded context. Generally, not always, generally, we can, and in fact usually do, which I'm going to demonstrate, have multiple services within a single domain bounded context. However, generally we do only have one database. Now, we may have reasons to partition that database into two separate physical databases within our bounded context. One reason might be CQRS, Command Query Responsibility Segregation, where it's too long to wait for those inserts. We need to read extremely fast. So we may separate physically the database into a columnar database for fast reads, fast writes, something like Cassandra. We may use a graph database, Neo4j, for super fast reads. We may optimize that way. But generally, we're breaking the data up but replicating it. It's still the same data context, the same ubiquitous language of that data meaning within that bounded context. So what do you think? When I ask this question, do you know what the answer always is? 50-50. Half of you would think, oh, keep it a single service. Half of you would say, no. Single purpose is SMS texting. No. Single purpose is notification. Do you see what happens? This is why service granularity is so hard and why we get into trouble. Do you remember when we looked at modularity and saw all those lines going everywhere connecting? Embrace modularity, but beware of granularity. This is where we get into trouble. And I'll show you exactly those lines in a bit. But yeah, 50-50. This is subjective. Now, let me show you another service. How about this service right here? We have a customer service, and this particular service manages all of our customer profile, preferences in the website, and also comments that I post about certain products or services. One service within our bounded context, or each of these being a separate bounded context? Interesting. They're still part of the customer domain or context. But here, it's a little more clear, isn't it? If I poll audiences, 20% of you would say, no, I'd still keep it a single service. That is its bounded context. 80% of you would now say that should be 3 separate services. Because the cohesion is not as tight. But it's still subjective, isn't it? Let me show you 4 other drivers that are not subjective. Demonstration defeats discussion. Remember, we're here at DDD, Europe. Demonstration defeats discussion, Europe. Yeah, I like that. Now you've got 2 definitions. Great, thanks, Mark. Now you just ruined my life because I can't use DDD anymore. Somebody's going to say, wait a minute, are you talking about domain-driven design? Or are you talking about demonstration defeats discussion? Great, thanks, Mark. You've just overloaded my common term. Yes, but we can actually generate metrics and show and demonstrate and justify breaking our service apart. The first of these is code volatility. For example, let's go back to our notification service. Single service. I can go into our Git repo, and I find that SMS texting and email rarely change. Matter of fact, they haven't changed in 9 months. But I can demonstrate to you, because you already know, that letter changes all the time. Each letter that we send our customers is manifested through a template pattern using classes. And lawyers love to change the grammar all the time. Oh, yeah, we got to switch those words around. Well, if I change this all the time, what's my testing scope? It's everything, folks. I have more to test. What's my deployment scope? It's that entire service, which means if I can't do a hot deploy, when I deploy, SMS texting and email are down. That's not good, because we need those all the time. I've got a lot more deployment risk, a lot more testing effort, because only one part of this service changes. This is a great disintegration driver. Break it up into 2 services. Notification, electronic notification, SMS, text, and email are both electronic forms. That rarely changes. But look what I've effectively done. Within the same bounded context, I've isolated my code volatility to a letter service. A lot less testing scope, less deployment risk, and when I deploy, which I can do anytime, I'm not disrupting SMS texting or email. The third driver happens to be scalability and throughput. So this is something else I can measure, and I do. So I look at my notification service, and do you realize we send 220,000 texts a minute, about 500 emails, and only one letter? What does this single service within that bounded context have to scale to? 220,000 requests a minute. Yes. What's my mean time to start for this single service? 6,000 milliseconds. It takes 200 milliseconds for SMS texting, that functionality to spin up. It takes 1,800 milliseconds for email. And because I have to instantiate those SMTP connection pools, letter takes 4,000 milliseconds. Because what it does is it actually generates and prints letters. And so consequently, that functionality starts looking for, scanning, connects to printers, checks the printer's health. 6,000 milliseconds. That is our mean time to start. Ouch. But if I break this apart into 3 services, now I can optimize in terms of the number of instances. Where do we need our scalability? SMS, 10 instances of that, 2 instances of email, and only 1 instance of letter. That could all be in the same bounded context if I'm sharing data. If each of these have their own data, which would be unlikely, then there might be 3 separate bounded contexts. What's my mean time to start for what I need on throughput and scalability now? 200 milliseconds. That's how fast I can respond if all of a sudden we get a flood of customers and they need to use SMS texting for multi-factor authentication. That's pretty cool. And the fourth is fault tolerance. So let's go back to our notification service. Well, it turns out that we have a unified service, but email seems to have, because we're using a third-party kind of service or tool, the SMTP connections have this weird, unpluggable memory leak. So email goes down, as does everything else. Ow! What's my mean time to recovery? 6,000 milliseconds. However, if I break this up, now, when email fails, guess what? That's the only service that goes down. SMS texting and letter are both perfectly fine. Stop. Wait a minute, Mark. Just one question. Why did you separate out SMS texting and letter? I mean, both of those are very reliable. Why make those 2 services? No, I think you're right. What would you name it? Non-email? I like that. What does that service do? Not email. No, I know, but what does it do? Non-email. Oh, right. Yeah. How about this one? Reliable notification service. What does it do? Reliable notification. No, I know, no, but what kind of notifications? Yeah. You might be tempted to do this. Oh, this is easy, Mark. SMS letter notification service. Uh-huh. And when we add Slack notifications, oh, now I have to name it SMS Slack letter notification service. Oh, and we're going to do Facebook Messenger. Oh, now you get the point. This goes back to the first driver, that first one, cohesion. If you have trouble naming something, what it typically means is those services, the residue that's left out of there, should be split up if you can't find a good name. Previously, we used electronic notification and letter. That's pretty clear what that does. But when you start appending SMS letter, the reason why you're doing that is because they are not cohesive. Okay. And there's one last one, and that is about security and access control. We have a customer service here, profile service, that manages the profile in your wallet. And that's all the credit card info. But we want that to be more secure. Well, requests are coming into here. How do I determine what requests can get into credit card or profile? It's code. It's all just code. But guess what? That request is already in your service. By breaking this apart into a profile in a wallet, my access control is now at a higher level. It's at my security layer, it's at my API, it's in the service mesh, not in the source code. This is a big difference. Okay, so yes, can we have multiple services? Oh, absolutely. And there's the drivers for breaking them apart, but not so fast. Because that's only half the story. We have to balance that with integration drivers. And the first one is transactions, folks. So we take our profile service and we say, well, we should have passwords as a separate service. I think that would be good for access control and code volatility. We don't change that often, but we change profile a lot. What happens when we register a customer? Profile security info come in encrypted into the profile service. Profile says, yep, this is data mine, but the security info, I have to pass that on to the password service, which further encrypts and then inserts. Folks, I do not have a database or ACID transaction anymore. I can't do commits and rollbacks. And my trade-off of this is data consistency and integrity. Oh, we had great reasons to break those apart, but that transaction is more important to us, which means, whoops, we went a little too far. We better put that together. Now I can do transaction.begin, transaction commit, oops, error, transaction rollback, and I get atomicity, consistency, isolation, and durability. Okay, that's the first one. The second integration driver also has to do with data, and it's the dependencies of the data. So here's our service, and it talks to this particular database with 6 tables. Well, let me show you. Demonstration defeats discussion, DDD. Let me show you the metrics. We should break this up. Oh, you are so right. But now we have to break apart the data because each of those are in a separate bounded context. How do we do this? Well, typically the owner of the data is the one who writes to it. Well, let's do this. So function A actually writes to tables 1, 2, 4, and 6. Oh, but it reads from 5. Okay, whatever. Function B writes to table 3, but reads from 2 and 5. Function C writes to table 5, so it owns it, but needs to read from 1, 2, and 3. Okay, let's form physical bounded contexts. The service owns its data. Well, tables 1, 2, 4, and 6 move over to service 1. That wasn't so bad. Table 3 moves over to service B. And then table 5 moves over to C. Fantastic. Great. Bounded context. Oop, but wait. We have all the access points because A needs 5, B needs 2 and 4, and C needs 1, 2, and 3. Our data, unfortunately, is highly semantically coupled, meaning I got to go and ask you for that data. Dude, I still need it. That is how we end up with a distributed monolith. Best recourse, if our data is that highly dependent on each other, is to basically put this all back where it was before. Yeah. And our third integration driver happens to be workflow and choreography. So here's our service right here, and I say here, demonstration defeats discussion. This should absolutely be 4 services. Yeah, I think you're right. But the problem is here we have highly semantic functionality. All these services need to talk to one another, not for data, but to execute your functions. You know, yesterday, user went in, did a query, and all of a sudden came back in 1,500 milliseconds. We released this partitioning last night. That same user comes in, makes that same request. It goes from here to here to here. 4,500 milliseconds. We've got network latency, we've got data latency, we've got process latency, we've got security latency, and we have marshalling latency. Good luck. That's that spider web of stuff I showed you in modularity. And also, we're going to have reliability and data consistency problems. What happens if I do a query and this service all of a sudden becomes non-responsive? What do we tell the user? Try again. What if that were an update? Commit, 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 crash. There's no transaction.rollback, folks. Yeah, that's tough. Ouch. So these are the integration drivers for saying, no, you should keep that service coarse-grained. Don't break it apart. Let's go back to our question. How many services in a bounded context? 1, maybe. But let's learn about our service within that bounded context. See if we can apply disintegration drivers. Or maybe, if we're already assuming 3 services, apply the integration drivers. If we break up services and break up corresponding data, we now have different physical bounded contexts. We lose transactions. We may need data that we no longer can access. And it's going to be a lot slower and much more unreliable. It really is, everybody, about this balance of balancing the disintegration drivers with the integration drivers. So we took a look at modularity, the breaking apart of systems into multiple parts, and I gave you 7 reasons why. Ask yourself, if you are in this position of migrating or creating a distributed architecture, do we need any of those why pieces? Can I really justify it? Ask why. It gives us better context in terms of what we're trying to achieve. And then, focus on the granularity. Because as I showed you, that's where we get the spider web of connectivity. So, wow. All right, fantastic. Thank you all so much. I think we probably have time for a couple of questions if there are any out there. So let's see what we have. I think we got three minutes. So yeah, a couple of questions. If
We've got 10 minutes.
Okay.
Lunch only starts at 1. So.
Oh, okay. I am holding up lunch. Whoops. All right, no questions. No.
So who wants the cube?
Any questions?
They all want lunch. I'm sorry.
They all want lunch, yeah. Either that or I guess I really thoroughly explained everything. Huh? That was awesome. Okay.
Or you lost them all.
Or I lost them all, yes.
Yeah.
Well, I'll tell you what. I am here all the way through Friday at the conference. It's easy to find me because I'm the guy with the gray hair and gray beard, so I stand out really well. But yeah, if you think about something or want to have a chat about this stuff, please find me at the conference, and I'd be happy to have a chat with you. So anyways, enjoy lunch, and thank you all so much. Okay, thank you.
Thank you, Mark.
All right, thanks.
Thank you, Mark.